Sustaera targets cheaper direct air capture with new design. A North Carolina carbon removal startup says it has made a notable efficiency advance in direct air capture, DAC, a technology designed to pull carbon dioxide directly from the atmosphere, but still challenged by high costs and energy demands. Research Triangle Park-based Sustaera reports that its proprietary electro-thermal DAC architecture could significantly reduce capital costs compared with conventional thermal systems. The approach pairs nanostructured sorbent materials with integrated electric heating, allowing the system to release captured carbon dioxide more efficiently during the capture cycle. Most existing DAC technologies depend on high-temperature thermal processes to regenerate sorbent materials. Those systems often require large, continuous energy inputs and substantial supporting infrastructure. Sustaera's design instead applies electric heat directly to the sorbent material. According to the company, this configuration has delivered operational efficiencies exceeding 90% in testing, well above the roughly 40% efficiency levels typically associated with traditional thermal DAC processes. Company leadership says the system architecture also simplifies certain infrastructure requirements, which could reduce capital investment. The company estimates its design may lower capital costs by 3 to 5 times compared with conventional DAC approaches, though large-scale validation will ultimately determine whether those projections hold. If the reported performance translates to commercial projects, it could help address one of the main barriers that has slowed adoption of direct air capture technology. Carbon removal market eyes the sub-$100 threshold. Within the carbon removal sector, one of the most closely watched targets is reducing the cost of removing carbon dioxide from the atmosphere to below $100 per metric ton. Many analysts and corporate buyers consider that level a key point at which demand for engineered carbon removal could expand significantly. Sustaera says its efficiency improvements could move the technology closer to that benchmark. Achieving those economics would allow DAC to compete more directly with other removal pathways, such as biochar and nature-based approaches that currently dominate the voluntary carbon removal market. The DAC industry has faced scrutiny after some early developers struggled to deliver the removal volumes associated with previously sold credits. First-generation systems were often energy-intensive and difficult to scale, while later designs improved performance, but still depended on large baseload energy supplies that can be expensive or difficult to secure. Sustaera is pursuing a licensing model that would allow project developers to integrate its capture technology into their own facilities or carbon utilization projects. The company says that approach could lower project development risk and accelerate deployment by relying on partners rather than building every facility itself. The system also operates without water consumption and produces purified water as a byproduct, a characteristic the company says could allow installations in regions where water availability is limited. Sustaera has received backing from a range of climate-focused organizations, including the U.S. Department of Energy, Breakthrough Energy Ventures, the X Prize for Carbon Removal, the Grantham Trust's Neglected Climate Opportunities Initiative, and RMI's Third Derivative Accelerator.